Welcome everyone, and thank you for joining our February webinar of the Ocean Climate Solutions Innovation Exchange. My name is Liliana Bastian, and I'm Program Officer at the UN Decade Collaborative Center for Ocean Climate Solutions, which is a collaborative center of the UN Ocean Decade hosted here at Ocean Visions. So this webinar is the last one for now in a series on measurement, reporting, and verification, or MRV, for ocean-based carbon dioxide removal, or CDR. We're hearing from 3 scientists today doing really exciting work in modeling and observations in this space. And we have a few hundred people signed up for today. I saw a lot of familiar names on that list, but I see some unfamiliar ones as well. So I'm going to start with a quick background on the series before I turn it over to our speakers. All right, so at the Ocean Visions UN Decade Collaborative Center for Ocean Climate Solutions, a really long name, we're working to advance global literacy and enabling policy, regulatory, and social environments for ocean-based solutions to climate change mitigation. One part of that is to bring emerging innovations in ocean science and technology to a wider audience. And so we use this webinar series to hear directly from the people working on all aspects of ocean climate solutions about the most recent developments in their work and what steps they see as needed to advance the field, particularly with respect to collaboration across sectors. We are hosted at Ocean Visions, which is a field-building network organization advancing research and development in the areas of ocean-based emissions reduction, ocean carbon dioxide removal, ecosystem repair, and a strengthened global ocean climate solutions community, which we call REACH. And so as I mentioned, today's webinar is the third and the last in a series we're doing on MRV for ocean-based CDR. As you might know, this area is receiving major attention in funding and policy based on momentum and scientific innovation. And we've heard from our audiences how much interest there is in digging deeper into different aspects of MRV. I just wanted to flag that the first 2 webinars of this series are posted on Ocean Vision's YouTube channel. The first one was an introduction to MRV for ocean-based CDR. And the second one spotlighted 2 startups who are suppliers of ocean-based CDR. So if you'd like to check those out, you can go to Ocean Vision's YouTube. And this webinar today will also be recorded and posted there as well. So yeah, let's get started. We're going to have 3 8 to 10 minute presentations from our speakers, followed by about 20 to 25 minutes for Q&A with the audience, moderated by Nikhil Neelakantan, who's Senior Program Officer at Ocean Visions, who leads our work in startup advising. We do have a chat function on the webinar today, so please use that to introduce yourself to everyone and make comments on the content that you're hearing. But if you have questions for the speakers, put those questions in the Q&A function. And you make use of the upvote feature in there, so that way we can see which questions are receiving the most interest and make sure that we get to those. So our speakers today are Dr. Raphael Ouillon, CTO and co-founder of atdepth MRV, Dr. Alicia Karspeck, co-founder and director of research and operations at Seaworthy, and Dr. Ellen Briggs, senior scientist at Aquatic Labs. Raphael is going to kick us off, so go ahead and share your screen when you're ready.
Great. Thanks, everyone, for joining. So I'll very quickly introduce myself. I'm Raphael Ouillon. I'm the CTO and co-founder of atdepth MRV. We're an MIT spin-off company, and really our goal is to bring cost-effective and scalable MRV solutions to the ocean CDR space. So today we're talking about specifically innovations in modeling and observations, and I didn't want to spend too much time repeating what has been said in the previous webinars, but I still wanted to have one slide on the quantification problem of ocean carbon dioxide removal. Most ocean CDR technologies work indirectly, right? They don't directly remove CO2 from the atmosphere. Instead, what they do is they affect the properties of water. They can either remove CO2 from water, or they can increase the capacity of the water to absorb CO2. And then they let that water, through natural ocean processes, pull CO2 from the atmosphere and draw it into the ocean. And really the biggest challenge facing the industry is how do we quantify how much CO2 effectively gets removed from the atmosphere and stored in the ocean via these natural processes that, again, are taking place in the open ocean. What the academic research is starting to show is that this measurement, reporting, and verification step, or this quantification step of ocean CDR, will require a combination of numerical ocean modeling and in situ measurements. But I wanted to spend a bit of time, before we talk about innovation in ocean modeling, I wanted to talk a little bit about what is ocean modeling in the first place. We often hear, even in the previous webinars, that ocean data cannot fully characterize the carbon drawdown of an ocean CDR operation. And there's a couple of reasons for that. The main ones are that the processes involved in the carbon removal in the ocean really cover a wide range of spatial and temporal scales. So you have some really important ocean processes taking place very close to an operation, but then you have things like the carbon drawdown and the air-sea flux between the atmosphere and the ocean that can take place over hundreds of kilometers and weeks or months of time. Then you have the fact that the ocean is always moving, diluting, dispersing, and so signals from a specific operation very quickly become indistinguishable from noise. So if you have sensors that are in the ocean, say a kilometer or two away from an mCDR operation, the signal that you get from those sensors is going to be very difficult to tell if what you're seeing is related to the operation, or if it's natural variability in the ocean, or if it's noise. It's going to be difficult to interpret. And so the end result is that data from ocean sensors will remain too sparse and limited, even as sensors get cheaper and we can put more of them to measure CDR operations. And so the conclusion is that we need ocean carbon modeling to complement the ocean data. But what is ocean modeling? I think in this day and age, when we think about modeling, we're really thinking often of very large data sets and then techniques like machine learning or AI to try and make sense of that data, right? To try and extract information from large data sets. But ocean modeling is quite different. And I wanted to start by sort of looking at two broad categories of modeling. One is empirical modeling and one is mechanistic modeling. Empirical modeling is really about finding patterns that connect output and input data to create empirical relationships between the two. So we look at large data sets, we use tools like statistics, machine learning, AI, to try and extract information from the data sets and build empirical relationships. And that applies a lot to things like soil decomposition models in the soil carbon space, for instance. Mechanistic modeling, on the other hand, we're using our understanding of fundamental physics to derive mechanical relationships between the output and the input data. So if you have the input data with mechanistic modeling, you can predict and simulate the output data. An example of a field that leverages this is fluid mechanics. And again, the point here is that ocean modeling is mostly mechanistic modeling. It also has an empirical component, but it's mostly mechanistic. What we do is we simulate the physics of the ocean to predict its evolution. And so ocean models and ocean modeling in general is not built on data sets. It's built on what we call numerical simulations. That being said, there are some really important caveats. You still need really specific and targeted data to inform parts of the simulations. So you still need sensors near a CDR operation to inform your simulations and your ocean models. And there's a number of models, particularly biogeochemical models, that are needed for MRV that require more empirical approaches and are more reliant on large data sets. So we still need to get data for those. So mechanistic modeling of the ocean requires what we call ocean modeling codes. These have been used and validated in academic research for over 20 years now, and they've been used to study a host of ocean and biogeochemical processes. The problem is that the ones we are currently using, particularly in academic research, tend to be slow, cumbersome to use, and they need to run on really expensive supercomputers. And so in their current form, these are not cost-effective solutions to quantify marine carbon dioxide removal operations. And here I have a nice visual from probably the largest ocean simulation ever run. It was run by a team of researchers using a code called MIT GCM. And here you can see some nice patterns of ocean currents off the coast of Patagonia. And this image comes out of a model that simulated the physics of the ocean to get to this picture. So I just want to say a few words about the approach that we're taking at atdepth MRV. We're building a multi-scale ocean carbon simulation platform to provide scalable MRV for ocean CDR. In our system, we want to continuously integrate in-situ monitoring data into a mechanistic simulation system. We're using novel codes that have been developed at MIT that runs over 100 times faster than these legacy ocean codes. And what that let us do is run multi-scale simulations from the global ocean scale down to the near operation so that we can resolve all the details of an ocean CDR operation. That lets us replace ad hoc data-driven empirical models, which are expensive to derive and are quite specific to a location and an operation. And it makes the most of the near field monitoring data, right, going from this input data to the output data. This is development that is supported by the Department of Energy via their CCO2 program in the RPE branch of DOE. And really our goal with atdepth MRV is to enable the industry by providing independent, cost-effective, and high-certainty quantification of ocean carbon dioxide removal. So I'll just leave with this one slide. What we're looking to do in the near future is to collaborate in pilot operations, ocean CDR, but others as well, like restoration projects, get access to data so that we can test, validate our system, calculate the uncertainty associated with our system. We want to collaborate on defining the best practices for the field, methodologies and protocols for MRV, data and reporting requirements, model validation procedures, etc. We want to conduct intermodal comparisons so that we can build trust in the models that we're using and further assess the uncertainty associated with ocean CDR. We want to collaborate with universities and public institutions on research projects, contribute to other kinds of projects like I was mentioning. For instance, ocean restoration projects can also benefit from these kinds of ocean modeling approaches. We're thinking in particular of seagrass restoration, and generally provide ocean simulation capabilities to the field. All right, thank you very much. Looking forward to the Q&A.
All right. Thank you so much, Raphael. I will turn it over to Alicia if you want to go ahead and share your screen. Let me unmute you, Alicia.
Am I unmuted? Hi.
Perfect.
All right. Hi, everyone. So I just want to start by saying thank you to Liliana and Sarah and Ocean Visions in general for the invitation to come speak here today. And also to Raphael, because it's a great introduction to some of the same topics that I'll be covering here in this short conversation. So I want to talk about a bit about modeling and monitoring as both key elements to the mCDR quantification. My name is Alicia Karspeck. I'm the Chief Technology Officer at Seaworthy. Let me tell you a bit. Let's see if I can advance. Yeah. So I want to just spend a slide or two just telling you a bit about Seaworthy. So we are a nonprofit R&D organization with a mission to build scientifically supported software that helps to quantify the efficacy of ocean-based carbon dioxide removal for MRV. And we are supported by a combination of federal grants and philanthropic funding. And we consider being nonprofit a really important part of our mission because it allows us to really independently look at this problem of MRV for mCDR. And because we are technically focused and we are mostly modelers, we think about this through mostly the lens of modeling, but also through thinking through the different roles of observations and modeling in this space through a really important part of our program, which is about actually engaging in field trials. So let me just spend a few slides again talking about why quantification of ocean-based CDR is so difficult. And this is really following along on some of the same concepts that Raphael already covered. When we think about ocean-based carbon dioxide removal, this is actually a process of carbon dioxide removal that will happen over very, very large spatial and temporal scales, which makes it very difficult to think about this as purely an observational or in situ modeling problem. I'm going to show you just a few slides, which are a simulated simulation from the CESM ocean model, which is going to be a ocean alkalinity enhancement simulation. You can see the injection site here. And what that looks like in terms of the PCO2 anomaly in the surface water over time. You're looking right now at the injection site. If we follow on just 1 year in advance, you see that we've already reached out into a signal that's at the basin scale. And by 15 years, which would be about the amount of time it would take for full equilibration in this particular region, we see that there's an entire basin scale signal from this. So the idea of being able to monitor this over this spatial and temporal scale really is not amenable to in situ observations alone. One of the other issues, and again, this was something that Raphael mentioned, is that there's a very unfavorable signal to noise ratio. So there's a lot of intrinsic background variability in all of the carbonate chemistry and also the flow and the CO2 fluxes that make it very difficult to detect a very small signal. Let me just give you an illustration of that with this movie. So what we're looking at here is just a movie of CO2 flux as it's evolving over about a year. This is again simulated with a coupled version of the CESM model run at 1/10 of a degree. And you can see that the signature of background variability of the CO2 flux, which is purely natural, is really picking up these signatures not only from the large scale circulation of the ocean, but also from the mesoscale circulation, and also the signature of the synoptic variability of the atmosphere itself. When we think about a CDR signal of CDR flux on top of this, you can imagine it's about an order of magnitude less than what you see here in the natural variability. And so this is related to this other issue, which is about this concept of complex baselines. So you'll hear a word a lot, I'm sure, in any time you're thinking about CDR, especially CDR in natural systems, of the idea of additionality. So the idea here is that when we think about carbon removal, it needs to be carbon removal that would have otherwise not happened if the intervention wouldn't have taken place. When we think about that from the ocean perspective, what that means is that we have to have some mechanism of trafficking would have been that natural variability in the absence of that. And so all of these things really lend themselves to the idea that you have to bring in numerical models into this idea of quantification. So again, as Raphael mentioned, mCDR really happens across scales. And I just showed you kind of a lens on that was actually very much a regional to global scale lens on that. But of course, the CDR happens from the micro scale all the way up to that global scale. And so we like to think about sort of breaking up these different scales as a way to think about what are the appropriate MRV systems that are amenable to these different scales. So let me just walk through a couple of those. You know, we spend a lot of attention on basically the mCDR intervention scale. So we think of this as the scale where an actual deployment of, for example, direct ocean removal or ocean alkalinity would take place. There's a lot of specificity at that scale, specifics to the actual method of deployment and to the region where it actually is taking place. The next scale we think about is the local to the regional scale. This is the area where you would cover in about a couple days to all the way up to a couple weeks to a month, where you have this initial dispersion of your signal, and there's these region specific dynamics there. And then out to the regional to basin scale, where most of the air to sea CO2 transfer takes place. So we have to think about modeling across those scales. And again, then we think about MRV across those scales. So I want to just walk through what some of the tools that we understand are kind of in our arsenal for thinking about these different scales. So in the near field, right, we really have this ability to think about project level actors. These are the people who are actually doing deployments, being able to do important monitoring of the biogeochemical and physical flow and state. And there is the possibility of actually detecting and monitoring some of the perturbations for that CDR signal. So that's a really, really important scale when we think about the participants who are coming in from the sensor space. There's a number of models that are really useful at this scale. We can think about the models that are needed for dissolution kinetics, for the dispersion parameterizations and plume modeling. Again, Raphael touched on some of those issues. And of course, high resolution, full three-dimensional physical and BGC models. Out to the local and regional scale, what's interesting there about the monitoring and of the BGC and physical flow state is we start to need to rely a bit more and bring on these regional to national actors in terms of the observational systems. An example of that is IOOS, the US Integrated Ocean Observing System, these regional networks. It's very unclear at this scale, actually, whether or not we can detect specific CDR perturbations. That's an area of active research right now. We're engaged in that in Seaworthy, and there's a number of other actors who are engaged in that. And another important tool there then is starting to get to the nested regional physical biogeochemical models. We tend to work with a model called the Regional Ocean Modeling System, ROMS, which is an open source tool for regional ocean modeling. It has a lot of the same features as the codes that at depth MRV, but a lot of differences too, especially in terms of computational performance. Out to the regional to basin scale, now we're really relying on monitoring systems that are at the national and international scale, like the Global Ocean Observing System. And really the consensus here is that we're really unable to detect and unlikely to detect the signature of any individual project. We may be able to detect the collective action of mCDR, but not the individual project at this scale. And at this scale, there's also a nice feature, which if we start to get out to the scale where there's a lot of possibility of standardization across different modeling projects and thinking about relying on common resources for that MRV. So in the last just few minutes, I want to make a quick plug because we talked about what some of the important kind of steps needed in the space right now. Seaworthy, we're engaged in 2 field trials right now. They're both ocean alkalinity enhancement field trials. One was in partnership with the Carbon to Sea initiative, and that's at an Icelandic fjord. And one is funded through the NOAA NOT program in the San Francisco Bay. And I wanted to highlight these field trials because we're having the experience at Seaworthy of really having an incredible amount of rapid learning in terms of how models and observations are starting to come together into the MRV and starting to get a bit more specificity that I want to share just some early thoughts with you as my final slide. And again, these are kind of early lessons from our experience. The entire community is really learning along this line with us. And I think an interesting way to think about this is not just separation into scales, but in terms of these different parts of the deployment process. So you can think about actually doing things like a field trial or actually a commercial deployment in terms of these stages of planning, deployment and operations, and then this long-term quantification. And within each of these, there's actually a myriad of different activities that have to take place that require both observations and models. I'm going to name just a few here because I think it's worth keeping in mind how complex these operations really are. When we think about planning, for example, we are doing things like site characterization, which is a model plus obs activity, deployment and engineering strategy, which starts to bring in kind of an engineering process and engineering codes, regulatory and compliance strategies, community engagement, where we can think about models for communication, and of course, having kind of business predictions or projections in terms of our accounting strategy, which is also something that models are used for. Deployment and operations, there is, again, this need for sort of a continual refinement of our processes. We need to be monitoring for regulatory compliance, which is a monitoring problem with observations, and then also doing continuous monitoring for that CDR accounting process. And then as we move then into this sort of long-term quantification problem, we're more and more relying on models to do that work for us. But we also need to think about observations and models for linking some of the project scale CDR that's happening with the need to have good global and regional carbon accounting budgets. So that's my final note there. I want to end just with a picture here of our amazing Seaworthy team. We are a young but growing team. I would encourage anyone here to go to our website and reach out to any of the people on our team to talk about the work we're doing. I didn't really get into specifics about some of our projects, but we're happy to have those conversations with anyone. Thanks so much.
Thank you, Alicia. That was awesome. Let me unpin you. And Ellen, if you could share your screen when you're ready, we'd be happy to hear from you.
Okay. Hi, I'm Ellen Briggs, Senior Scientist at Aquatic Labs, and I'd like to say I'm honored to be speaking to everyone today on behalf of the observations side of the MRV story. So just a little bit about me. I was an assistant professor at the University of Hawaii. I did a one-day meeting in DC in January 2023, and I met Alan Adams, founder of Aquatic Labs. 6 months later, a series of events catapulted me to join Aquatic Labs in July 2023, which uprooted my family, 2 young children, a dog, leaving our house behind to experience New England winter for the first time. So why on earth did I do this? So for starters, I felt this real sense of urgency for the need for transformative tools to enable and support MRV. And this startup space operates at a different pace, strategy, different priorities relative to academia. So in my lab at UH, I have a handful of graduate students, which were great, but it required a lot of training, mentoring. And as a tenure track academic, I had teaching and service obligations. So I was no longer the one in the lab making the progress. And so when several groups reached out to me within the mCDR MRV community about when they could get their hands on the sensor tech I was developing, I really felt a push out of academia and pull into the startup space to really accelerate progress. Additionally, one of my motivations is we also really need accountability standards, best practices in this space. And I'm really excited to be a spokesperson on the value of the ocean and the need for observations. And so why Aquatic Labs? So the vision at Aquatic is to create a new generation of massively deployable tools for pervasive, persistent, and real-time sensing throughout the world's waters. So what that means is let's approach this differently than we have ever been able to do before. So I want to dive in a little deeper into the need for observations, and this is not in any particular order. We need to build trust in the market. Investors and communities want to see actual data, not just models and forecasts, but ground truth data. Observations are essential for helping constrain models and ground truth models. Environmental impacts and permitting will require observations. If we look at marine renewable energy as a proxy, data collection and observations were a critical component for setting up the regulatory process and for permitting purposes. And we will likely see a very similar a trend in the mCDR space. From a science standpoint, the equilibration kinetics are determined of the CO2 uptake and exchange is determined by a complex interplay of gas exchange and surface residence time, which has a great uncertainty, especially when you think about plumes expanding over these large volumes. And so having observations to help better constrain some of those is going to be very useful. And models alone are not the answer, and observations alone are not the answer. We need to work together in a sort of iterative way where models help inform where we collect the observations to feed into the models to better help inform where we need more observations to again feed into the models. And the current state of the field is we have a severe problem of undersampling. And so I like to point to this example in the Southern Ocean, where through the SOCOM project, so the Southern Ocean Carbon and Climate Observations and Modeling Project, peripheral floats equipped with biogeochemical sensors have been deployed in the Southern Ocean starting in 2014. So you can see this blue line in the right-hand plot shows percent area sampled in different zones in the Southern Ocean. The red line corresponds to observations collected from more traditional platforms, primarily ship-based. And you can see that there's a lot of seasonality in when areas were sampled. And that's primarily due to inaccessibility. The winters are really hard in the Southern Ocean. But when we include that biogeochemical data from SOCOM profiling floats into our estimates of carbon flux in the Southern Ocean, we get pretty significant offset from relying on the more traditional methods alone. And this is a result of sampling bias. So, summer versus winter, but also just severe undersampling in general. If we look at this area sampled, we're going between 0 and 10% and often real close to zero coverage. And in terms of MRV, we don't have a clear idea at this point of what is satisfactory in terms of percent area coverage to give the appropriate spatiotemporal coverage. And so traditionally in oceanography, we make shipboard or ship-based observations, and each one of these transects is completed once every decade, roughly. And this has provided us with very excellent snapshots in space and time. However, ships are very limited in their ability to provide the larger spatial temporal coverage that is likely required for MRV. And part of the reason for this is that seagoing efforts are extremely challenging. There's rough seas, you have to avoid bad storms, it's hard to access certain areas that are covered in ice. It involves a lot of complex instrumentation. Going out to locations to make observations takes a lot of time to just get there, and the measurements themselves take a lot of time. And on top of all of that, it's very expensive. So it's really hard to get the observations in the first place. And so we've resorted to relying on autonomous vehicles to really fill in the gaps in both space and time for our observational program. So this is the Global Ocean Observing System. But it's important to point out that for each of these dots, they don't represent measurements of the full aqueous carbon dioxide system. And this is primarily a result of a lack of availability of transducers or sensors for measuring the full CO2 system parameters. And so now if we really want to have a massively pervasive, deployment of measuring systems for making observations of the marine CO2 system, we really need to develop sensors that meet a certain design criteria. So ideally, they would be solid state, reagentless, low power, agnostic to platform, and be able to manufacture at scale, which reduces cost. And with the potential market of MRV, this can be enabled. And so historically, and we would make one-offs or tens to hundreds of certain sensors or platforms. But now we really want to think about how do we make hundreds of thousands of these and get them out into the ocean. And that really changes how you design a sensor and a platform. It really pushes you to think outside of the box or traditional pressure housing, so to speak. And so the project I lead at Aquatic is the development of this solid state sensor for pH and total alkalinity on a single chip. And so this is a reagentless sensor that is very easily to manufacture at scale. On the far right here, I show titration data for measuring total alkalinity in seawater, where the measurement took 20 seconds to reach the measurement endpoint. So it's a rapid sensor, it's low power, and it meets a lot of those design criteria for being something that can be massively deployed in large scale. And so I just want to leave with this remark from Walter Munk that more often than not, new ideas have come out of new technology rather than the other way around. So advances in platforms and sensors have really revolutionized the way we can observe the ocean and what we are just general understanding of the ocean and oceanic processes. And oceanography hasn't really ever seen a market on the scale of mCDR and MRV. And so we have this really exciting opportunity to do this right. And so I just want to give a shout out to our really awesome growing aquatic team. We're working on a whole variety of different sensing solutions with this scalability in mind. And so I would love for those of you in the community to reach out to us to, see where we're at and find ways to work together and collaborate so that we can do this right. Thank you.
Ellen, thank you so much. That was really cool to see. I know that there are some efforts within the UN Ocean Decade at making sensing technology cheap and accessible, and then deployable at scale. So very cool to hear about that. Let's get started with the Q&A. We're going to have about 15 to 20 minutes for a Q&A. So Nikhil, go ahead and get started.
Great. Thanks, Liliana. This has been a really interesting set of presentations, and I think a fitting finale to our three-part series on MRV. Just as a quick introduction, I'm Nikhil Neelakantan, Senior Program Officer for Ocean Visions, leading our Remove program. So a number of really interesting questions have come up, but let me just start with one of my own. What do you think are the key differences between scientific research on mCDR and measurements and modeling and operational fit-for-purpose industry-ready MRV? And this is addressed to all three of you.
Yeah, that's a great question. I don't know if anyone wants to get started. I'm happy to get started on that.
Go ahead, yeah.
So there's a lot of similarities, right? And it's a lot about adopting what this scientific research is producing in terms of tools and adapting that to, commercially viable MRV and effective MRV. There are some key differences from a technical perspective. I think one of them is that academic research is often focused on case studies. So we're going to look in a lot of details at one specific question for, a specific region, specific period of time, often, and quite limited in time. So you might really study what happens over a week or a month, get a lot of data, do a lot of modeling, and understand that with great detail. But I think for MRV and for operational MRV, we're going to need tools, and Alicia mentioned that we're going to need tools that continuously quantify these processes, right, at all these different scales. And so there's a different challenge. It's almost more of an infrastructure and logistics challenge in a way. How do we go about doing that, continuously in a way that's cost effective? Because the resources that you can put in a 2 weeks long or 2 months long academic research study are different than what you'd need to put into something that's going to have to be in the ocean for 10 years and continuously quantify operations. And so that goes for the modeling. How do we do continuous modeling or continuous simulations? And how do we continuously get data from the ocean into our modeling systems?
Quickly follow on to that. So I'll just say a few things about my observation of kind of having entered into this space of Seaworthy, where we're taking on this role of trying to think through this question about what are the needs, what are the needs in terms of the MRV for the markets? What does that imply about the additional research that's needed to be conducted by kind of the academic sector? And I would say it's quite distinct and pretty interesting in the sense that I think there is a tendency from the academic side to think about this problem mostly from kind of a traditional way of thinking about carbon budgeting in terms of sort of global scale, regional scale, process level budgeting, which is a really great and important piece of this problem. When you start thinking about the need to actually do what I would call a project level accounting, so this idea that we need to actually do quantification in such a way that enables a market to take place, it opens up actually new questions, which still have to be answered by the scientific community, but are framed slightly differently. I'll make just a quick example to tell you, kind of give you a sense of how I'm thinking about this. One issue that kind of flowed through both my talk and Raphael's talk was this concept that as we move out to larger and larger spatial and temporal scales, we can decrease the resolution of our models for quantification. In fact, that is an open research question, and that is a research question that is something that what I would like is to see the larger academic community start to tackle that question. But it's a question that's very much inspired by the practical problem of mCDR accounting.
Yeah, I just wanted to add that we still need partnerships between, industry and academia. We need to work together, but it is a slightly different focus and a different lens.
Great. Yes, speaking of partnerships, there were a couple of questions around how organizations like the three of yours and others in the ecosystem, how are they working together to share data and the basis of the models to speed up the learning process? Another flavor of that question, are there international or industry-led organizations that can help standardize or coordinate these challenges outlined by the panelists?
I can just give it a try to start. Raphael, were you going to go? Sorry.
No, I was going to.
Okay. It's a great question. I want to say one thing, which is my experience is that this is obviously a very young industry and a very kind of young across all these sectors. And that the experience I've had so far is that there is a huge willingness across actors from all of these sectors and across all these entities to work quite closely together in terms of sharing their learnings and sharing their perspectives. I think you'll see a lot that there's a lot of these young companies, I'll put us in that category as well, that are finding our way. We're pivoting our way towards finding what the right niche is for these different parts. And that's very natural and I think organic piece that's happening right now. There are a number of organizations that have started in consortiums, which are starting to try to kind of coalesce some of these activities and coordinate some of these activities. Seaworthy, because we're in this nonprofit space, we are able to act in some of that, I would say, coordination. I wouldn't exactly call it convening, but in terms of trying to drive consensus and try to understand who are the different sort of consensus building actors in this space, and how do these different actors in this space sort of work together.
I guess I'll just say a quick word to add to that. So we're in a different situation with atdepth MRV. We're a for-profit company, and again, our goal is to provide MRV services to the industry. And so in that sense, we're paying a lot of attention to the work that everyone is doing in the industry and talking to everyone. And our goal is to make sure that what we're providing, meets the sort of the requirements and the best practices that are available today when it comes to MRV. And I think there's a lot of ways to collaborate with all sorts of entities, from private companies, nonprofits, academia, and we're seeing that more and more. There's still a real need for funding to go into MRV, both on the scientific side of things and on the commercial side of things, so that we can test these different solutions, not just CDR technologies, but also MRV technologies, right? So we can test them, validate them, compare them, so that we can further reduce uncertainty. And I think there's there's a lot of opportunities to do that. I was mentioning in my presentation, inter-model comparison is a great one. If you take two different models that have been developed separately and you can show that they agree on the results provided the same data, then you're already one step closer to saying, okay, we can start trusting these models. And I think there's a lot of opportunities to do that. But the more funding we get into the MRV space, the less uncertainty we'll have about mCDR as a whole.
And I would like to give a shout out to what Irene posted in the chat. Carbon to Sea initiative is a big player in, coalescing these groups and involved in, standardization, et cetera.
Yes, thanks. And Irene's put her information in the chat as well.
I'm going to add in to the chat just a whole list of some of the convening organizations, Carbon to Sea included.
Thanks, Alicia. Raphael, you spoke a little bit about funding as a barrier. So what are the other barriers that you see, either at a broader scale or the organizational level scale, to scale up high quality MRV, and what support do you need to address that?
Yeah, I think we need pilot operations that have both the CDR component and the MRV component, right? So I think, practically speaking, we need opportunities to go and test and validate a bunch of different solutions that mix modeling, that mix monitoring, that put both together. I think then, of course, there's a question of the role of regulations, registries, methodologies, right? We need to have methodologies in place and protocols in place so that we can have a framework in which to operate. But I think, again, this is progressing in the space, and we're going to see the emergence of the first methodologies soon. So it will be a matter of continuing to evolve those and make sure that they improve as the science is improving as well.
Yeah, from a tech development standpoint, historically, from like an ocean science view, we've been severely underfunded, and funding has been inconsistent. My work on the alkalinity sensor, for example, went through at least 1 year without any funding. And so it really changes your approach to developing tech when, there are uncertainties. You kind of scrape to get by just to get the data, to get the paper, and then move on to the next step. But if your our goal is to make this, device that can answer this particular solution for this really large market, you approach it with a completely different angle, and it opens up so many new opportunities that are really amazing and really exciting and really fun.
One other point that hasn't been mentioned here in terms of what it takes, is going to take to kind of scale out the MRV, is this issue, which I know affects Raphael at atdepth as well, is this issue around the need for quite a lot of high performance computing to support some of the modeling work. I mean, there is a tendency to sort of have a blind spot around the real costs associated with high performance computing. A lot of times those costs are borne by, and traditionally have been borne actually by, the science agencies, which has led to a situation where people are in some ways sort of, again, blind to what these true costs are. An important, again, models are not the only answer, but the limitations that we face from actually fully utilizing our models to their potential due to not having access to enough high performance computing are real. And it's one of the big pieces of work that we're doing at Seaworthy. I know atdepth is doing this as well, is sort of spreading the word around that need to think through strategies for how this entire industry is going to get access to sufficient high performance computing.
Thanks.
Sorry, Nicola. I just wanted to ask one thing to that, which is that, MRV for commercial ocean CDR is also going to need to be cost effective, right? And that's another blind spot, I think, that goes along with what Alicia was saying, which is, if we need MRV to be science-based, but we also need a way to make it operational and cost-effective for the industry. I think otherwise we risk a situation where science-based MRV is considered too expensive and it drops off the map, and we're left with MRV practices that are just not sufficient to quantify carbon dioxide removal in the ocean. And we end up in a situation where we're not promoting the technologies that are doing a good job because we don't have a way of quantifying that effectively. So there's, I think, really a need to strike that balance of science-based MRV, but also cost effective so that it's adopted by the industry.
Yeah.
Thanks, great point. I think we have time for maybe two more questions. Matthias Cape asks, assuming that multiple concurrent deployment of different mCDR interventions will be needed, how do you think about carbon accounting and assessment of potential interactive environmental effects of the deployments? And I just wanted to add how, if at all, you're thinking of the environmental impacts and effects of these deployments as part of MRV or separate.
Yeah, I think I can get started. I think that's a great question. I think it really goes to the point of additionality. How can we tell what a specific operation is adding to the carbon budget, right? It's not just a matter of understanding the global ocean carbon budget, but it's also understanding what a specific operation is doing and whether there's interference between two operations. Maybe they add up to more than their individual parts, and maybe they add up to less. So I think this is really aligned with what Alicia was saying, that commercial ocean CDR creates new academic and scientific questions, right? It's not the same scientific questions that are asked previously when looking at the carbon budget. Now that's a new scientific question that's emerging because of this nascent industry. Another point that I wanted to make, and again, it comes from a point that Alicia was making in her presentation about near-field processes and continuous near-field monitoring and modeling. The near-field is really where you can tell a specific operation apart from the background, because that's where the signal is very strong. And so I think there's a real role of what we do very close to an operation. How do we quantify that? And how can we make sure that we can keep track of the information of that specific operation as we go to the regional and global scale?
And as the observationalist, I would just like to say, like, we will need, observing strategies. And like, mesocosm type studies, process studies. So that's where like a really like a scientific partnership is really important. But having long-term observational programs that can help tease out, could this be just natural variability, or could this be some unintended consequence of intervention? Maybe it's a positive thing. It's not always negative, but being able to tease that out, I think will require like that, combined effort with an observational program.
Just to add on one point to that, I think I love this question because the whole issue of how to do accounting and attribution to a different project, to various projects, is a very, very thorny question, actually. And it's a question that is one that has to be addressed not only by the scientific community, but really by the market community and the regulatory community all collectively, right? And when we think about doing this problem, we have to think about it through a number of different lenses. One is, what is our ultimate goal in doing this accounting? Which is that we all have an ultimate goal, that we actually have credible removals from carbon dioxide removals from the market. But then the other question we might want to answer is, what do we want in terms of the collective action, and what does that accounting look like? And so I think the issue here around this is that this is a conversation that really can't be just adjudicated within the scientific community, but really has to be a kind of a broader question to be answered, and one that is likely going to have kind of an emergent characteristics, meaning we're going to have a dialogue, across these sectors over many years in terms of coming up with the right strategy for dealing with these complex accounting issues.
And I think there was a second part of the question. Sorry.
Yeah, go ahead.
I
with the
just
second
realized
part.
that you were talking about environmental MRV, and we sort of
Oh, yeah.
skipped over that. But that
Right.
is a great question, and we could spend a lot of time just on that as well. I think
Yeah.
I'll say that a lot of the monitoring and modeling practices and technologies that we're developing can also track other things than carbon, right? And they have to, in any case, to get to the carbon removal. And so that it can include things like the turbidity in the water, any chemical quantity that we can track in the ocean. I think there's an interesting point here, which is that there's a lot of existing industries that are affecting the ocean in many ways, right? And with this effort to better quantify carbon, we're also developing tools that are going to help us better quantify all these other human interventions in the ocean. So there's a real opportunities to use the technology that we're building here for carbon in many other maritime industries and better quantify their environmental impact.
Thanks, Raphael. We're almost out of time, but I did have to ask this one question. So we have 1 minute. So what gets you all excited about the MRV space where we are right now?
I'll start with my perspective on it. I mean, what I love, and I think I've touched on this a couple of times about this moment in time, is really the bringing together of these different interested parties in this problem across all these different sectors, from academic, from commercial, from policy, from government. I think it's an incredibly rich space, actually. And the other thing I love about it is that it's a space that is creating great jobs for people who are oceanographers and ocean modelers and who really care about making a difference in terms of the climate crisis. All of those things together make it really an incredibly exciting space to be at this moment.
I was just going to say that it's a really exciting time to be in this space. The number of people that throw around the word total alkalinity has changed from just a handful to however many now. So it's just kind of fun and exciting that, you know, what I've thought was really fun and exciting for maybe a little bit longer time, other people are jumping on board too.
Yeah, I agree with what both Ellen and Alicia said. I'll just add one thing on our side. We're really excited because there's all these novel ocean modeling technology that's emerging on the academic side of thing, and we're excited about seeing that brought to maritime industries. It's entering through this ocean carbon dioxide removal question, but we think that it can really change the way we approach quantifying human interventions in the ocean in general, and it extends beyond ocean CDR.
Hey, with that, yeah, over to you, Liliana, to wrap up.
Okay. Yeah, thank you to everyone. That was so insightful on so many levels. Loved hearing about the combination of modeling and observations, the importance of multi-sector collaboration. And then if you look at the chat, it's been very, very educational and useful for the audience. So thank you so much for your presentations. And we'll invite you, if you're comfortable, to add your email into the chat so that people can contact you if they have questions or want to learn more. Before I go, I just wanted to quickly invite everyone to connect with Ocean Visions and the Decade Collaborative Center for Ocean Climate Solutions at the upcoming Ocean Sciences meeting in New Orleans. Ocean Visions staff are participating in 6 events related to mCDR and partnerships for ocean science, and we're also holding a booth there. So if you go to the site linked here, which maybe Nikhil can put in the chat as well, you can see a list of those events, and we would love to see you there and chat with you there. So yeah, with that, thanks again to our speakers and for Nikhil for excellent moderation of the Q&A. And feel free to give feedback in the post-webinar survey that should pop up after you close out. And I hope everyone has a great weekend. Thanks, everybody.
Thank you so much. Bye.
Bye.